Okay, what we are going to do today is going to do a quick little video about complex numbers. Complex numbers are found on paper 1, right? In complex numbers, the question, you'll either realize it's complex numbers because it's talking about z's and they're in the form a plus bi, or at the end of the sum it'll say I squared equals minus 1. Right? In terms of complex numbers, you need to know how to plot them. So in terms of plotting them, you've got two axes, right? The one going flat across are your reals. The one going up and down, so in other words, your vertical axis, is your imaginary. Right? So normally when you're plotting points, you go out the x, up and down the y. This time you're going out the real, up and down the imaginary. Okay? After you plot them, you need to be able to add and subtract. You need to be able to multiply them. Get the conjugate. In terms of conjugate, they'll either use the word conjugate or they will write z with a little bar on top. All right, they'll say get the modulus, which is your z in between two straight lines. Okay, it's representing the length of z. So it will be the length of z, a particular point, to the origin. And finally, you have to be able to divide complex numbers. All right, so if you can do those 6 things, you'll have absolutely no bother doing complex numbers, and they are on paper 1. All right, so just going through the first bit. If you get asked in a question to add and subtract complex numbers, it's exactly the same as algebra, right? You're going to add and subtract the real numbers with the real values, and you're going to add and subtract the imaginary numbers with the imaginary numbers. So the parts of the sum without the i's, you add them together or group them, and the parts with the i's, you group them, right? If the sum gave you your different parts as Z1, Z2, and Z3, when you are writing it out, make sure you use brackets. The reason you have to use brackets is normally the sum will have a minus sign in it, and your minus will carry across the bracket. Right? So if, for example, the sum said you had Z1 being equal to minus 2 plus 3i, Z2 being equal to minus 3 minus 2i, and Z3 being equal to 6 plus 3i, and they asked you to get Z4, and in terms of what they're telling you, Z4 is Z2, take away 2Zi. So you write it out using brackets. So instead of writing Z2, you write down bracket minus 3 minus 2i, put your minus sign down, 2, and then your Z1. Okay, in terms of the sum, you're going to do your multiply first. So we haven't done anything to the first bracket, so we leave that alone. So minus by minus will give you a plus, and you get a 4. Minus by a plus gives you a minus, and you get a 6i. Right? Now, in terms of this bracket was just there to group it. Okay? It's not representing multiplication because there are plus signs behind it. Okay? So what you can do is just remove that bracket. Then you are going to group. So in terms of your grouper, you've got real, imaginary, real, imaginary. So you're going to group the reals together. So we're going to have a minus 3 plus a 4. Okay, so in terms of that, my 4 is bigger, so I'm going to keep the plus sign. So my answer will be plus 1. Then I have a minus 2i and a minus 6i. Both of those are minus signs. So I'm having a minus. And 2 and 6 will give you 8. So we get 1 minus 8i, and that is my answer. So that would be Z4. So in terms of Z4, the real part is 1. The imaginary part is minus 8. So if I had to plot that, I'd have my two axes. Plus 1 would mean I go out this way. I'd go out as far as 1. Minus 8i would go down here as far as minus 8. So where the 2 would cross over, I would do a dot, and I would call that Z4. Okay, so you go out the real, up and down the imaginary. Okay, so that's adding and subtracting. So it's exactly the same as algebra. You just have to remember to write down it in brackets first. All right, so I know it might seem silly, I know it might seem like a waste of time, but write it down. It will save you time in the long run. Okay, the next thing you have to do in complex numbers, move the page around so you can see, is multiply. All right, so multiplication. In terms of multiplication, multiplication is like algebra again. In terms of that, you'll be splitting the brackets. You'll be multiplying two brackets together. All right, so at the end of the sum, you're going to sub in I squared has been equal to -1. So everywhere there's an I squared, you're going to replace it by -1. All right, and you have to remember to tidy up the sum at the end. In terms of, sometimes in the questions it will ask, what is the effect of multiplying by an I? So multiplying by an I moves the point 90 degrees. So basically it will move it to a different quadrant of your frame. So if a sum had asked you to solve for z, right, and they had given you this. 2z is -6 bracket 4 minus 6i equals -1 plus I in one set of brackets, 4 minus 2i in another set of brackets. What you have to do here is these two brackets are totally multiplying each other, and this bracket is being multiplied by a -6. Okay, so if we started off our 2z, nothing has happened to 2z, so you just write that down. -6 by 4 gives you -24. Minus by minus give you a plus 36. And we have an I. Write your equal sign down underneath where the equal sign was. For this thing, we are splitting the bracket. So what we have is we have a -1 times the second bracket plus I times the second bracket. All right, so we have split this bracket. It's like you imagine a little line going down here, and then this times all of that, and this times all of that. All right, so when you're multiplying out, you're going -1 by 4 will give you -4. -1 by -2 gives you plus 2i. Then we'd have a plus 4i and a minus 2i squared. Okay, so when all that's done, we tidy up a bit. So tidying up in here, we've got z's, we've got numbers, we've got i's. So I don't have to tidy anything here. Here we've got a -4, we've got i's, and I squareds. So I'm tidying it up. I get 2z minus 24 plus 36i equals -4 plus 6i, and then this I squared, I'm going to change it to a -1. So -1 by -2 will give me a plus 2. All right, so in other words, what I'm doing is I'm writing down the the coefficient in front of the I squared, which in this case is -2, but just changing its sign. So -2 became plus 2, and I don't write down the I squared anymore. Okay, then I'm tidying it up again. So I have 2z is equal to -4. This came over, so I got plus 24 plus my 6i, and then I got minus 36i because it went over, and plus 2. So 2z is equal to 24, take away 4, which is 20. 20 plus 2 is 22. 36 minus 36 plus 6 gives me minus 30i. That's 2z. I want z on its own, so z is equal to 11 minus 15i. And that would be that sum done. Okay, so again, for multiplying, it's like your algebra. Remember to split your brackets. So like this. Don't forget to multiply the last half. At the end, sub in I squareds are equal to -1 and tidy it up. All right, the third part for complex numbers is conjugates. And for conjugates, conjugates mean, or the sign for it, the symbol for it is Z with a little bar across the top of it. In terms of your conjugate, you're changing the sign of your I. So if you got told Z was equal to 4 plus 3i, the conjugate of Z is 4 minus 3i. If they told us Z was equal to 6i minus 2. The conjugate is equal to minus 6i minus 2. So it's not necessarily changing the middle sign, it's changed the sign in front of the I. Okay, so just watch the order of the letters when you're changing them around. Okay, fourth bit is your modulus. Modulus in English stands for the distance from the point to the origin. If you get modulus in the exam question, it will be written like that, as your z within two straight lines. The formula for modulus is you square the real value and you add it. It's always an add. Always, 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 always a plus to the imaginary coefficient squared. All right, so you don't write down the I squared, you only write down the coefficient, the number in front of the I squared. So if it just said I, the number would be 1. If it said 2i, the number would be 2 squared. Okay. If the sum has asked you for z1 plus or minus z2 in a modulus sign, do the addition and subtraction first before you get the modulus. So here's a little example again off the papers. Z1 they gave us as 1 plus 3i, Z2 was 2 minus I, Z3 was Z1 plus 2Z1. Right? So we want to investigate if Z2 take away Z3, the modulus, is the same as Z1 plus Z2, the modulus. So for us to do this, we have to first find out what Z3 is. So Z3 is straightforward addition. So Z3 is Z1. Remember to write it down with brackets. Okay, so write it with brackets. Get rid of the brackets. So we've got 2 and we have 6i there. Tidy it up. So reals with reals, we're getting 3 plus 9i. So that's Z3. Okay. In terms of sum, they want Z2 take away Z3. So for Z2, take away Z3. I write down Z2, which is 2 minus I. Take away my 3 plus 9i. Okay, so write it down with brackets. Get rid of the brackets. So this minus became minus 3 and minus 9i. So that's the reason you have to write the brackets. Again, tidying it up, 2 take away 3 is minus 1. Minus I minus 9 gives you minus 10i. Okay, so that's this bit, but we want the modulus of it. So the modulus of Z2 take away Z3 is equal to the modulus of minus 1 minus 10i. So the method is we square the real. So we go minus 1 squared plus we square the coefficient of the imaginary, so minus 10 squared. And when you do that, you're getting 1 plus 100. So for that, I'm getting 101. Okay, we want to compare that to the modulus of Z1 plus Z2. So Z1 plus Z2. Z1, again, write them down with brackets. Get rid of the brackets. Tidy them up. Okay, so for Z1 plus Z2, we're getting this. So if we want the modulus of 3 plus 2i, that means you're getting 3 squared plus, it's always a plus, 2 squared. So you're getting 9 plus 4, which is root 13. So the question was, where is my question? Is the modulus of Z2 minus Z3 equal to the modulus of Z1 plus Z2? All right, so my Z2 plus Z3 was equal to 101. My Z1 and Z2 is equal to 13. So 101, the square root of it, is not equal to 13.